are living through revolutions, multiple revolutions in single lifetime. I believe most of us will see 3 major technological revolutions during our lifetimes. And the first one has already happened. That was the internet revolution. And I guess the best way to illustrate how the internet revolution has already happened is to look at how my work has changed during the quarter of a century I've been working with computer security. Because when I joined the company where I work today, F-Secure, in 1991, the daily work wasn't that different from the daily work today. You have an office with computers. Every desk has a computer, PC or Mac. You have geeks and nerds coming in the morning, spending the day banging at the keyboard, and then going away in the evening. That's what we did in 1991. That's what we do today. But the difference is that in 1991, the PCs and Macs we had on our desks were not online. And when I say online, I don't just mean that they were not on the internet, because of course they were not on the internet in 1991. They were not even connected to each other. In 1991, our office did not have a LAN. We had no local area network. So when you were working on one computer and you needed the files on another computer, we used the thumb drive of the 1990s to move the files. This is how we worked. This is the revolution which happened. And the second revolution has already started. That's the IoT revolution. If we've now seen every single computer on the planet to go online, next we will see everything else going online. If it uses electricity, it will be online. Every device will become a smart device. And I am the father of the Hypponen law, which says that if something is smart, what you should be thinking is vulnerable. Smart phone, vulnerable phone. Smart watch, vulnerable watch. Smart car, smart city, smart grid. You get the idea. And if we are lucky, if we live long enough, if we go jogging and eat salad, we will live long enough to see the third revolution, which is going to be real AI revolution. And of course, we have a hard time defining what we actually mean by real AI or strong AI or wide AI. But, you know, just for entertainment purposes, imagine that one of the projects that right now tries to simulate the full human brain succeeds during our lifetime. And we come up with a mechanism of moving actual memories and processes from real brains to computers. If that's going to happen during your lifetime, you will never die. If that's going to happen during your lifetime, you will never die. In fact, we have no way of knowing if this has already happened. And we're not real. It might be that we're actually running in a computer program. We have real brains running in a real computer program, but we don't know we are in a simulation. So yes, we're living in times of technological revolutions. With any luck, 3 revolutions in our lifetime. And this has implications for our safety, our security, and our privacy. And not all these things that technological revolutions bring us are good, not all of them are bad. It's clear that the internet has brought us more good things than bad things. Exactly in the same way, machine learning will bring us good things and bad things. Let me give you an example of something beneficial. Our research labs around the world analyze hundreds of thousands of malware samples a day. On a typical day, 500,000 samples. On a bad day, 700,000 samples. Well, it's quite clear when you have hundreds of thousands of samples that there's no way we can analyze every single sample with humans. We can't. And we haven't for 8 years. For the last 8 years, we've been building what we initially called a labs automation project. Nowadays, we actually call it our machine learning project. because it's a system which learns what's good and what's bad. We collect hundreds of thousands of samples, we run them through a variety of different virtualization systems, and then the machine learns, is this good, is this bad? Should we allow this to happen, should we not allow this to happen? So that's a clear benefit, and that's practical. You're all using this on your computers today, because every single software security solution, whether it's on your PC, Mac, or phone, it's relying on a cloud backend, and the cloud backends today from every security vendor rely on machine learning. This is the power of machine learning in practice. So, this is the famous Kasparov match between the IBM Deep Blue and Garry Kasparov. 1997, first time human loses to a machine in chess. And before this, before 1997, the way we would define what's artificial intelligence was that when we get a machine that can beat the best human in chess, then we have artificial intelligence. Then the machines are smarter than we are. Well, then it happened 20 years ago. And we suddenly changed our minds. Well, actually, that's not intelligence. It's just calculating. It was just calculating. So we keep moving the goalpost. We keep redefining what we mean by real artificial intelligence. But if we entertain the thought of a machine that can simulate the whole human brain, I think we could all agree that if that's possible, then that would be real intelligence, because it would have emotions. It would be us. And there are several interesting technological developments which are changing our world. Deep Blue, the machine that beat Kasparov, is a great example, because Deep Blue was a massive machine, 90 gigaflops in processing power. It had its own power source. Well, if you take the phone from your pocket, that phone has 70 times more processing power than Deep Blue. Your phone beats Kasparov in chess. Your phone beats 70 Kasparovs at the same time. And it runs on a battery. It runs on a goddamn battery. Can you imagine the miniaturization of technology? How a room-sized computer, which requires its own power source, fits in our pockets. And if you look at the CPU power of iPhone X announced last week, that's probably going to be hundreds of times, maybe thousands of times faster than Deep Blue. It's massively fast in its CPU performance. And the real revolution, I think, will start with programs that write programs. A computer program that writes programs, which is easy to do. I've done a program which writes programs. But if you can imagine a program which makes itself better, enhances itself, and makes a better programming program, initially it's going to suck. But if we keep improving it year after year, it's going to get better. And then one day, maybe in 20 years, one day it's going to be as good programmer as me. I'm not a very good programmer, but let's say it's my level of programmer. All right? One day it reaches me. Well, that's the last day I ever have to program anything. In fact, it's the last day any programmer, anywhere, has to program anything at all. Every single programmer is out of a job immediately. Why? Because now that program is going to write a better version of itself, which is going to write a better version of itself. In 10 seconds, it's not going to be twice as good as me. It's going to be a million times better than me. In 10 minutes, it's beyond our capability to understand what it does. This is the exponential growth in machine learning and artificial intelligence. Another thing that's changing right now is the future of money. And we see this, and maybe I guess we hear about this all the time. We talk about Bitcoin, but I think the real innovation really isn't Bitcoin, it's blockchain. And blockchain is one of those innovations which is really obvious once it was invented. And that's how you know that an innovation is a huge innovation. That when somebody explains it to you, it's obvious. Like, okay, what is a blockchain? Blockchain is a public ledger of transactions. It's a public ledger of transactions. You do a transaction, such as money transfer, and that's public, and it's locked in place. It can never be changed because it's maintained by a peer-to-peer network. So it's a public ledger of transactions, which is really, really obvious, except nobody thought of it until 2009 when Satoshi Nakamoto invented it. This is how you know it's a great innovation. It's obvious once it has been invented. So right now, most of the things we hear about cryptocurrencies, whether it's Bitcoin or Ethereum or Sia coin or Litecoin or Dogecoin, we hear that they are booming in value or fluctuating in value, or they are being used by criminals. They're used by criminals. He's not a criminal, he's the guy who invented Ethereum, actually, Vitalik Buterin. So criminals like the group behind Petya, one of the 2 large ransom Trojan cases of 2017. The other one was WannaCry. But I wanted to use this image in my slides because it's an image of an infected ATM machine, which is funny. Because normally, when you go to an ATM, you go asking for money, and now it's the ATM asking money from you. And sometimes people ask me about how come we can't follow the money. Like when someone pays a ransom for Petya, why can't we follow where the money goes? Because it's in blockchain, and blockchain is a public ledger of transactions. Public. We can see the transactions. Why can't we just follow where the money goes? Well, we can try. This is the Petya blockchain. This is the wallet used by the Petya criminals in blockchain, the small circle in the center. On the 2nd of July, they moved some of the ransom money from their wallet to 5 other wallets. Then on the next day, they moved it from those 5 wallets to quite a few other wallets. This is the problem. We can try to follow the money movements, but it becomes very quickly very difficult, especially when they move money between different cryptocurrencies, especially to currencies like Monero and Zcash, which are double-blind systems. This is a complex problem, and this is the reason why online criminals love cryptocurrencies. It's the same reason why real-world criminals love cash. It's hard to follow the money. So what about then the future of technology? One thing we can't wait to see in our everyday lives is self-driving cars, because that's going to take away traffic jams. Self-driving cars will kill traffic jams. We will no longer have traffic jams, which is great. And this is going to happen, hopefully, as soon as possible. But then when we speak about threats on self-driving cars, one thing people immediately think about is evil hackers hacking cars and driving us off the road. Well, that's possible, but I think what's much more likely is evil hackers hacking our cars to steal them. This is a CCTV footage of a car thief stealing a car, not by breaking the ignition lock and hot wiring it, by taking out a laptop. He opens the doors from the outside with the laptop, he gets in, he plugs in his laptop, his MacBook, to a USB port in the car and starts hacking away. And when you think about self-driving cars, I can easily see a situation where self-driving cars are converted into self-stealing cars. Imagine waking up and your car has driven off by itself. Another thing which is a good indication on how the threats we think about are different in the real world is that a friend of mine works for a company which builds trash can IoT sensors. Sensors you put in trash cans, and they will detect how full the trash is. And then you can optimize how often you go and empty the trash cans. Easy enough. They call this the Internet of Bins. And when they started deploying these in the real world, they realized that they are breaking up much more than they thought. They have a much higher failure rate. They couldn't figure out why they break up so often. And then they started looking at CCTV footage, and what they saw was that the trash can emptier truck drivers were breaking the sensors on purpose. The truck drivers were breaking the sensors. Why? Because before the sensors, they would go around once a week. After the sensors, they would go around once a month. They had much less work. And this is the humans fighting the machine. It's the man versus the machine. When we think about man versus the machine, we think about Terminator. No, 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 no. It's the trash can lorry drivers breaking the sensors because it takes them out of their job. You can imagine the programmers fighting self-programming programs because it takes them out of their job. You can imagine the truck drivers putting signs on stop signs to sabotage the self-driving trucks. That's man versus machine. Future of security, of course, is very close to the topic at hand. And we are the first generation that can be tracked throughout our lives. This is the NSA headquarters in Fort Meade. That's one example of world-scale blanket surveillance we're exposed. And we can be tracked because we use technology, because we live our lives online. Privacy has totally changed during our lifetime. That's one of the downsides of the internet revolution. And the number of connected devices is skyrocketing. You look at any Gartner slide and they will tell you there will be billions of machines online, but they don't tell you the real reason why. And the real reason is him, this guy. It's his fault. This is Gordon Moore from Intel, father of the Moore's Law. And we all know that the Moore's Law basically tells that the computing power doubles every 18 months. True, but there's the reverse of the Moore's Law, which is that the price of existing computing power halves every 18 months. And what that means is that the price of an IoT chip, a single chip which will convert a dumb thing to a smart thing, this is plummeting. And eventually that chip is going to cost 2 cents, or 1 cent, or half a cent, nothing. And when it's so cheap, that means that appliance manufacturers will start putting these chips in everything. Because they want to collect data. They want to collect data about where these appliances are being used. How are they being used? Where are they? Where are our customers? Where should we advertise? Where do we have lack of customers? Things like these. So it's not about converting machines to smart devices to give benefits to you, the consumer. It's about getting data to the manufacturers. And this means that very quickly you will not even know which one of your appliances and devices will go online and which don't. They look like dumb devices, but they will be smart devices. And they will not require access to your Wi-Fi to go online. They will be using new internet technologies like LTE-M or 5G or Zigbee 3. This is happening already. Everything will be going online, and you won't even know if your home devices are online or not. So what can we do about that? Well, at F-Secure, what we've been doing is that we've been building a device. This is F-Secure Sense. This is a home router that's different from your existing home router. It creates a Wi-Fi network for your home, which will then secure your IoT devices through the network. Because you will not be able to secure your IoT devices with antiviruses or something like that. You won't be able to install an antivirus on your toaster. All right? I work for an antivirus company. I will promise you, we will never make an antivirus for toasters. All right? So the only way we really can secure them is through the network. And this is what devices like these will be doing. And by the way, we're giving one of these away today. One of you will walk home today with one of these. If you come to our stand, the F-Secure stand in the hall, you can join our competition and win one of these devices for your home. So then we have future of conflict and future of war ahead of us as well. Because it's unlikely we've seen the last war in mankind's history. We all wish we would have, but it's unlikely to happen. And if you look at technology in war today, well, we already have self-flying drones, which kill people, which is a little bit worrying. But did you know that, for example, Samsung, the Samsung we all use as our televisions and as our phones, that's a weapons manufacturer as well. They make smart guns, which are able to detect their targets and even make the decision of shooting or not. They still have a physical button for humans to press, because we've decided that it's not good enough for machines to kill people completely on their own, but it could. And then there's another interesting development, the energetically autonomous tactical robot, which is a robot able to use biomass and continue operations at the field, at the battlefield, even without a fuel. All right? A fighter robot, which doesn't need fuel because it can use biomass. And it doesn't sound too bad until you realize that we are biomass. So this company that builds this prototype, they actually had to make a public statement where they said that we completely understand the public's concern about futuristic robots feeding on human population, but that is not our mission. Yes, I can also see why people would be concerned about robots eating people. So, whatever you do, don't kick the robots. This is what we always see on YouTube videos. People kicking robots, showing how agile they are. And this is a bad idea. Don't kick the robots. Don't kick the robots. Why? Because one day, those robots will be smart enough to go to YouTube and watch videos. And then they will be angry. Don't kick the robots. Thank you very much.